Okay, let's do these notes. These are the last ones that are going to be together for Math 2 and Math 3. Then we'll have different videos. So, first example we're going to start off with in box 1 is 2x times 3x plus 4. Okay, so write that down. And then I'm going to show you two ways that you could do it, and you can write in your box whichever way makes more sense to you, all right? So, first way over here is showing the distributive property this way, okay? And 2x times 3x, and then 2x times 4, that will get you 6x squared, that will get you 8x, and that's your answer. That method we're going to call the claw, all right? This other method is kind of like the activity we did in class. It shows it kind of as areas. So 2x times 3x is 6x, 2x times 4 is 8x, so that gets you the same answer, 6x squared plus 8x. Same answer. All right. Example 2. Same idea, but now we've got a monomial. Instead of times a binomial, it's times a trinomial. So the claw will go 1, 2, 3 places. 3 times 2x squared, 3 times negative 6x, 3 times 4, and get you this result. Or you can draw it this way with the box method and get the same exact result. All right, copy that down. Then we'll move to example 3, which will be a binomial times a binomial. So when we have a binomial times a binomial, you have to take the first part times both of the second two, and then the second part times both of the second two. So you're going to get 4 pieces that we'll add together, and you might have called that FOIL in the past. So 2x times a 2x, the 2x times the negative 3, the 1 times the 2x, the 1 times the negative 3. And then we'll add all those up, and the x terms are like terms, so they'll combine to become negative 4x. So we had 2x times negative 3 gave us the negative 6x. The 1 times the 2x gave you the 2x. Those combined to give you that. So the final answer like that. With the box method, this time you notice this and this part are both x terms, so you have to add those together just like we did over here. Okay, example 4. Another binomial times a binomial example. So same thing with the claw. You do this first to both of those two, then this to both of those two. Add all the parts up, and we'll get negative 2x squared minus 18x minus 36. And this is giving us the same exact thing, just showing it differently. Again, you got to combine the like terms, or add those like terms together to get negative 18x, and same result either way. Okay, example 5, we're going to do a little trickier, a binomial times a trinomial. Okay, binomial times a trinomial, same idea. You got to multiply the first term times all the terms in the second one, and then the second term times each of the terms in the second one. All right, and you can show that this way, or writing it out. Negative 2x times 3x squared would be negative 6x cubed. Negative 2x times negative x is plus 2x squared, because negative times negative makes it positive. And then negative 2x times 4 is minus 8x. then the 1 times each of those. 1 times 3x squared is 3x squared. 1 times negative x is negative x. And if you want to write that as plus negative x, that might make more sense. And the 1 times the 4 will obviously get us a 4. Then we gotta, did I do this part right? 3x, yep. Okay, so, no, this should be a squared. Sorry about that. All right, so now we gotta combine like terms. So this is the only cubed term in there. So we'll just write that by itself. The x squared terms need to go with each other. And that'll combine to 5x squared in a second. Then the x terms, I'll write it plus negative 8x plus negative x, and then the only constant term is the 4. So then those will combine and those will combine because we add like terms. 6x cubed plus 5x squared plus negative 9x, or you could just write minus 9x plus 4. That's the final answer. And showing it with this method, same idea, the 6x cubed, then these two terms are both x squareds and they'll add to the 5x squared. Those terms add together to the negative 9x, and this will give b by itself. So again, same answer, negative 6x cubed plus 5x squared minus 9x plus 4. So same answer either way. And so in this example, I tried to show a little bit. I realized in the previous, maybe you got a little confused with negative versus subtracting. But just remember, negative and subtracting are exactly the same thing. So that's what we're going to write a little note in box number 6. So let's say that you have, in case you're ever getting confused, let's say you have negative 6x squared plus 6x minus 3, and let's say that you want to add this other polynomial of 5x squared minus 3x plus 2. Okay, so whenever you have minus or a minus right here, it's the exact same thing as plus a negative. Subtracting a positive, you can always rewrite it as adding a negative. So I'm going to show that up here. So this one, negative 6x squared plus 6x, instead of minus 3, I'm going to write it as plus negative 3. And this one right here, 5x squared plus negative 3x. Because that's all that subtracting really means, is adding a negative. Or, yeah, okay. So, negative minus 3 becomes plus negative 3x, and same thing with that 3. So that can help you if you're ever getting confused with subtracting in the polynomials. Just write all the subtracting signs as, rewrite it as plus a negative. Okay, so that's the thing for box 6. Just remember that subtracting a positive is the same thing as adding a negative.